Question 8. A student oxidized. So what's oxidation? Oxidation is loss of electrons. Okay, oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. Oil rig. Okay, so something's being oxidized. It's losing electrons. Oxidation is loss of electrons. A solution of hydrochloric acid. So a student oxidized a solution of hydrochloric acid. So the hydrochloric acid is being oxidized, it's losing electrons, with a few drops of sodium chlorate 1 solution. We're going to have to work out what sodium chlorate 1 is. The reaction mixture effervesced, that means it made a gas and turned pale green, a pale green gas. The gas formed bleach universal indicator paper. Now chlorine's a pale green gas and chlorine is used in bleach products, so maybe we're making chlorine gas. Write a half equation for the oxidation of chloride ions. Now a chloride ion is a chlorine atom that's gained an electron. Chlorine, Cl, is in group 7 of the periodic table. It wants to gain 1 electron, so it wants to form Cl- ions and gain an electron. That's what a chloride ion is. Now if it's oxidized, oxidation is loss, so the Cl- ion is losing an electron. So it looks a bit like this. That's a chloride ion, a Cl, a chlorine atom that's gained an electron, a chloride ion. Remember, an ion is a plus or a minus charged atom. An atom that's lost or gained electrons to fill up its outer shell. So this chloride ion is a chlorine atom that's gained an electron to fill up its outer shell. If it's been oxidized, it's lost its electron. There it is, the electron's lost, and it's lost the minus charge. So it had a minus charge, which means it gained an electron. Now the electron's come off and it's lost its minus charge. It's just become Cl. Don't be afraid, by the way, a half equation involves electrons. It's got to involve electrons. If you don't involve electrons, if you don't see any E minuses in a half equation, you've got it wrong. The one thing that's not quite right about this is that chlorine atoms, if you make chlorine atoms, they tend to pair up in twos, because as we were saying, chlorine is in group 7 of the periodic table. So 2 Cl's can come together and each put an electron into a covalent bond, into a pair. So between 2 Cl atoms, Cl2 will form between 2 Cl atoms, where each atom puts an electron into a pair and form a covalent bond. So we know Cl is going to form Cl2. The issue then is that it doesn't balance. 2 Cl's, Cl2, 2 Cl's, I'll need 2 Cl minuses, and now I've made 2 minuses on the left, so I need 2 electrons being released on the right hand side. So 2 minuses on the left, 2 minuses on the right. And that's oxidation, because it's a half equation, because there's electrons in there. It's oxidation because something, the Cl minus, has lost electrons. The other way of looking at oxidation is it's a -1 ion. It's in oxidation state -1. Cl on its own, Cl2 on its own, is just elements. It's just an element. It's just atoms bonded together as a molecule. It's molecular, but it's just atoms. They haven't got any charges at all. So the Cl minus goes from -1 oxidation state up to 0. If it goes up, it's been oxidized, so that's gone from oxidation state -1 up to oxidation state 0. Write a half equation for the reduction of chlorate 1 ions to chlorium. Well, first of all, you've got to know what chlorate 1 ions are. You've got to learn that. A chlorate ion is like a chloride ion, except it's got an O in there. So it's a Cl minus, but it's got an O in there. To form chlorine. Chlorine in acidic conditions, we'll worry about that in a minute. Chlorine we know is Cl2, so I've got 2 ClOs making Cl2. By the way, why is it chlorate 1? What does the 1 come from? Well, it refers to the oxidation state of the Cl. Oxygen is in group 6 of the periodic table. It's got 6 electrons in its outer shell. It wants to gain 2 electrons and form a 2- ion. So it has oxidation state -2, a 2- ion in there, except it's only got 1 minus left over, which means that this must be +1. +1 -2 leaves 1 minus left over. So the +1 refers to the oxidation state of the chlorine. The 1 means that the chlorine is in oxidation state +1. +1 -2 leaves -1. And we know oxygen is -2. It's always -2 because it's in group 6 of the periodic table and wants to gain 2 electrons, gain 2 minuses. The one problem that I've got here is now I've balanced the Cl's, but I haven't got any O's on the right hand side, and I've got a minus on the left and no minuses on the right. So what do we use? What's in our armoury? What's in our toolkit that we can use? If we've got O's that we can't balance, we can always add H2O. And if we can make H2O, we're going to need H2O on the right hand side because we've got O's on the left, so we're going to make O's on the right. Now when you make H2O's, you've got H's in there now. You can always use H pluses, not H's, but H pluses. Acids provide H pluses. That's what acids do. They release or donate H pluses. So I can use H pluses and H2O's. I can always add that in. Let's have a look at that then. So that looks rather complicated now, but it's not really. Let's have a look what I've done. I've got O's on the left hand side. So I've made H2O on the right hand side. So I've got O's on the left and O's on the right. I said I could use H2O's to balance up the O's. I've got O's on the left hand side, I've got O's on the right hand side. I needed 2 ClO's to balance up the Cl2. So I've got 2 O's on the left hand side, so I need 2 H2O's to balance up the O's. 2 O's, 2 O's. Now I've made 4 H's. I said I could use H pluses. So 4 H's, I'm going to need 4 H pluses. Now let's work out why I've added 2 minuses here. On the right hand side I haven't got anything with any charges. There's no charges on the right hand side, so I need no charges on the left hand side. 2 minuses, 4 pluses. 2 minus and 4 plus means 2 plus. So I'll need 2 minus to cancel out the 2 plus. Let's add up all the charges here. 2 minus, 4 plus, 2 minus, 4 minuses and 4 pluses. No charges on the left hand side, no charges on the right hand side. Write an overall equation for the redox. That's some reduction here and some oxidation. I've got to combine everything on the left of these equations and everything on the right of these equations and then simplify and cancel. So what have I got on the left of this equation? I've got 2Cl minus, and on this one I've got 2 ClO minus, 4 H pluses and 2 electrons. So I combine everything on the left of these two equations. 2 Cl minus on the left of this equation, 2 ClO minus on this one, 4 H pluses and 2 E minuses. So that goes on the left. On the right hand side I've made Cl2 and 2 electrons. That goes on the right. And on this one Cl2 and 2 H2O. So I combine all those. So everything on the left of these two equations goes on to the left of the overall, and everything on the right of these two equations combines and goes everything on the right. Now, can I simplify this a little bit? Let's have a look what I've just done. Okay, I've cancelled out the electrons, so I've got 2 electrons on the left and 2 electrons on the right. That's important when you balance two half equations, that the electrons cancel. The half equations have electrons in them, but the overall equation can't do. We may come to a more difficult question where if we don't have 2 electrons on the right and 2 electrons on the left and they're not going to cancel, we might have to multiply through by a number so that the electrons on each side cancel. But on this, in this case, it's quite a straightforward one because 2 electrons are made on the right hand side of this equation, 2 electrons on the left, so the left hand and the right hand cancel. The electrons cancel, and that's why I've cancelled them out here. I've also combined Cl2 and Cl2 to make 2Cl2. So I've just simplified it. Now notice I've got 2, 2, 4, 2, 2. I could divide through by 2 and make Cl minus, ClO minus, 2 H pluses, so I've divided the 4 by 2, Cl2 and 2H2O, so just divided by 2, and I've now got an overall equation. A solution of sodium chlorate 1 was added to a colourless solution of potassium iodide. So what I've got is I've got chlorate 1 just as before, but instead of chloride making chlorine, I've got potassium iodide making iodine. So what I've got this time is instead of chloride making chlorine, I've got potassium iodide making iodine. So iodine is a black solid, but when it's in solution, when there's liquid around, when there's some water around, when it dissolves, it goes to a brown colour. So it makes a brown colour because it dissolves. So the black solid of iodine dissolves to make a brown solution. It's iodine because I minus is oxidized. So Cl minus was oxidized to Cl2. So I'm just going to finish that off my third mark by saying I minus is oxidized into I2. Remember what I was saying here about oxidation. Cl minus, oxidation state -1 going to 0, -1 going up. -1 going up means that there's oxidation going on, or you could say it's lost electrons, but the I minus would lose electrons, and instead of forming Cl2 would form I2. I2, as I say, is a black solid, but in solution it dissolves to go brown.